All right, I think we are ready. Um, I've got a couple of things. We've got some of the parts came in for the printer with the nozzles, those um, not copies, they're not like duplicate types, but the CHT Bondtech nozzle where it splits the filament into three. I found a much cheaper version, but a little bit different. Those came in, I haven't put one on. We've done a little bit of flow rate testing on what we do have. And then we're going to mainly do photogrammetry type stuff today. But let's look first at some of the printer things over here. And it's a big mess. We were doing these at one point. So you saw some of these last time. These were trying to get flow rate, not volume, not maximum flow, but just get the flow rate correct. I printed a lot of those, and these were the built-in calibration test for that Orca slicer has built into it. I think they're probably from Bamboo Slicer, which Bamboo Slicer is based on Prusa and the Bamboo ecosystem of printers. Orca Slicer is a open source version of the Bamboo Slicer and Prusa Slicer mixed together. Anyway, I think that's where these came from. And the idea with these is that you have a flow rate, normally in Orca Slicer, it starts out at 98% for PLA, or 0.98. And then you print these little things, and each one has a number. Oh, you can't see it. Sorry, you print these little things, and each one has a number on it of an adjustment. So go up 10, down 10, up 5, down 5, whatever it is. And you find the one that looks the best in the set. So you print about 8 or 9 at a time. And adjust your flow rate. And then you do so the first one's kind of like pass 1 is a large adjustment. And then pass 2, you print it again after you make that adjustment. And you get a more fine-tuned adjustment. I think I ended up, I don't actually remember, let me see, where did I end up at? Do I even have Orca Slicer open? I may not have it open right now. Oh yeah, there it is. All right, so let me see. Well, I'll let you see too, I suppose. Actually, not the web. There. Oh, that's a little preview. Let's see. It would be in the filament. So I ended up at 882, so 88.2%, so pretty low for our flow ratio, which is flow rate in other slicers, or just flow. Sometimes it just says flow. So I ended up at 88%, which is a little under what I would normally do. Normally I do drop down below 100%. I don't normally go down to 88%, but I've been printing at 88% and it works pretty well. So I'm at least with the filament I'm currently using. So it could change. Remember, the way that they handle it here is this flow rate is per filament. So, well, per filament type. So right now I've got this as generic PLA. Technically, I should go in and change this to, this is for a particular type of filament of PLA. Now, I'm not going to do that because I've got one roll of this filament and you can't get it anymore, so I'm not going to make a custom profile for what's left of this one roll. But, so then, after creating or kind of fine-tuning the flow rate, I did this calibration. And this one I don't think we did on the stream. I don't think I showed you this one. Maximum flow rate. So, all right. Now that I know kind of how much filament needs to come out to create a certain line width and things like that, then now I want the maximum volumetric flow rate. And I did that with these, 2 of these. So these little tests. Now we had been doing these, which would also do max flow rate, a bunch of these little guys. I'm not sure which one I like better yet. This one is a little more realistic. It's an actual print, but it's only one wall, so it you can kind of get away with stuff on one wall prints that don't really work on multi-wall or infill and all that kind of thing. So I'm not sure. These are slightly faster, so you could do these. the idea with these is that you weigh them. So you need a scale that's going to give you hundreds of grams resolution. So there's that downside. So faster, but you need some equipment. You got to do some plotting, put it in Excel and kind of figure out where it starts to drop off at. This one, you just hit print and let it go. This is another one of the built-in calibrations in that Orca slicer, also in the bamboo slicer. Plus, I've seen these outside of these slicers where you can use them on your own. I don't remember if the Teaching Tech site has this for volumetric flow rate, but it might. So this is the one I printed first. And I wrote on it 5 to 20. So the idea here is that maybe you can see those little lines. I don't know. There's some lines across here that are indicator lines. And the idea is that you start at one flow rate. So I started at 5, so really conservative. And then you go up by, I think it's 0.5 cubic millimeters per second per line here. Not per layer, but there are some little, maybe you can see them inside there. You can kind of see there's some artifacts down in there. Those are lines. I don't know if you can actually pick them up on the camera. But every one of those lines demarks a increase in flow rate. And so this one went from 5 to 20 cubic millimeters per second. Now, I'm a little not certain that it's actually 20 cubic millimeters per second because I had to do some line width modifications. The built-in version of this thing is assuming you have a 0.4 millimeter nozzle, and this printer has a 0.6, and so I'm not certain that it's actually correct, but I went with it anyway. So I know it's increasing the flow rate. I just don't know if it's actually increasing it to 20 or some number slightly less than 20. So that's what I don't know, because of the different size nozzle I have. But I tried to adjust for it. All right, so this one looked fine the whole way. So there was no problem. So then I made another one that started at 20 and went up to, I think, 30. And that's this one. I didn't even finish yet because you can see, can you see? Let's see. Yeah, you can see right there. It started having gaps. So it was not able to supply that much molten filament at that rate. So 20 was okay. But and you probably can't see on the camera, but right in where I put these dots at, those were not complete holes, but they were definitely under extruded. So it was struggling at that point. So what you do is then you go and you find what layer that lines up with. You can kind of almost see the lines on that one. And this one lined up with the 1, 2, 3. The last one was the third indicator. So I started at 20, so I went up to 20.5, went up to 21, went up to 21.5, and then beyond that it struggled. So that kind of told me that if my numbers are correct, the maximum flow rate, volumetric flow rate, 21.5 cubic millimeters per second. Now this one doesn't change temperature, so that's at one temperature. You know, these guys, you get an array of temperature changes and flow rate changes. So, you know, which is better? I don't know. I kind of like this a little bit more because here you can actually go in and measure the volume. Well, not the volume. Well, you could measure the volume if you had like a graduated cylinder or something. You could measure that volume, I suppose. But you can measure this exact weight and figure out the volume. And I kind of like this one a little more, but you do have to have some scale. Now this did not cost, this was like $10 off of Amazon. So it doesn't cost a lot, but you do have to have that. Otherwise you won't be able to do anything with these other than tell which ones printed and which ones didn't. So I did that. And what I ended up doing, let's see what I don't remember. On my filament, I set the max volumetric speed. I don't know why they, I guess they're calling it speed because they'll set the maximum printing speed based on the amount of filament you can flow. So I set it to 20. So I didn't go at the 21.5 that it maxed out at. I pulled it down a little bit. Also, I'm not quite sure that those numbers are even the correct numbers. So I set it to 20. And so what this will do, and you can do this in Prusa Slicer also, is it will never, when it's slicing, it will never try to produce any speeds that go beyond needing that amount of filament flow rate or volumetric flow rate. So I did that. Now, that's for one printing temperature for that particular filament roll. Probably I could drop down to quite a bit more conservative, 17, 15, something like that, and it would be okay for all of the PLA that I would print. All right, what else did I do? I did this one. There's no documentation for this one, but it does generate the file. This is, let me show you. This is in calibration more VFA. So there's in the tutorial here, there's no documentation for what that is. VFA, I've heard it called two different things, vertical fine artifacts and very fine artifacts, but most of the time I think it's referring to vertical fine artifacts. But the idea is that particularly on direct drive printers, but on other printers too, you might get surface imperfections that aren't due to anything other than the motions of the stepper motors themselves. So the stepper motors move in distinct intervals, steps, and those combinations of steps between your X, Y, and, well, in not necessarily Z, but your X and Y motors can create some artifacts in your print. Also on the direct drive printers, you've got the stepper motor almost directly attached to your filament, whereas on the Bowden tube there's a distance between, I mean, it's touching the filament, but the filament's got this big basically spring or capacitor of filament between where it's touching the feeder motor and where it comes out of the nozzle. But on a direct drive, that's very, very close. It's very direct. And so you can even get artifacts from the extruder on a direct drive printer. So printed this thing. Where's my right camera? Printed this thing, and it sits in there, I think, this way. So the front of the bed would be like this. So no, that where's 0? There it is. Something like this. So it'd fit on your bed like that. So it's got all these different angles: 0, 45. 60, 30, and 80 and 90 or something like that. I don't know what all the different angles are. But it will use different combinations of your X and Y stepper motors. Basically, it's what it's doing. And then it changes speed, printing speed, from the bottom to the top. So at the top up here, it was printing or trying to print, I think, 200 millimeters per second. And it started at, I don't know, something like 20 or whatever. And what the goal is, what I'm assuming the goal is that you're looking at the combination of all of these sides and trying to find where is the surface finish the best across all 5 orientations. And then you set your max print speed to that number. In truth, it's very similar on all of them. Like, there's not one little layer. Slow is not better, fast is not better, across all 5 different combinations. So none of them were horrible. I don't know if you can even on the camera, if you'll even be able to see the vertical fine artifacts. I don't know. Let's see if I can make it focus on that. No, it's not gonna. I mean, because they're very fine artifacts. But if you were holding this in person, you could see little lines. Like, let's see if I can get them the right way. They're little vertical lines parallel to each other in this print, and they are closer together down here. They spread out a little bit, and actually the faster I go, the better those artifacts get on that one. But on others, there's a band in here where they're kind of they're there. Here they're actually really pronounced. In general, the faster it's printing, the less those artifacts are noticeable. So if you're having some issue, and I can't even show them really well because they're so tiny, but if you're having an issue and they bother you, then you might try changing speeds or orientations of the part, because the different orientations will have different effects. Hold on, let me respond to this message real quick. Just have to fill this out. Okay. I'm not sure why it doesn't have any documentation for this, but that's basically what it's doing. Is it's printing faster and faster, and it's printing in different directions. So it's using just your X, just your Y, and then combinations of your X and Y stepper motors. And then it will give you an idea of if there is a printing speed that is ideal or one that beyond which you just don't get very good prints. Basically, this one didn't tell me any of that, other than if you print faster, the vertical fine artifacts are less noticeable on this. Now again, this is kind of a vase mode print, so it's one single wall. Here they do double up though on the little wings, so you get some interaction between the two walls. So I printed those. Oh, you might notice this area right here. So I'm liking this sheet. This is the PEO, I don't know what it's even called, but the pattern sheet. And it's the thing that generates the cool textures on the bottom of your prints, like those shiny spots. Maybe this one shows it up better. Yeah. So the problem I had was I printed a pressure advance test where it's just single layer lines going across here, and then it printed numbers on the board, on the bed, and they were squished too much. So particularly back in here, basically this wheel back here was too high, or this corner of the bed was too high, and these numbers were really squished in, and they would not release from the bed. So I had to scrape them off of the bed. I tried all sorts of different scrapers to get them off of there. Ultimately, this one is the one that scraped them off of there. But in the process of doing that, it scratched the bed as well. So now anytime I put a part here, then it's not going to have the nice texture on it anymore. So that is one downside to these beds. And all the beds that have some kind of texture on them, is that stuff that's only one layer will potentially not be able to be removed from the bed, and you have to scrape it off, and that might scrape and scratch your bed surface. So be careful with those beds. I did order a different one because sort of because of that, but there's still plenty of room over here for printing and getting the texture, and it works fine. I have printed stuff on top of that, and it does work fine as far as adhering, but I don't get that same texture on the bottom of it. I don't think I have an example of that right now, though. Oh, actually, this piece. I don't even know if you'll be able to tell, though. So right in here is where it overlapped that spot, and it's not as clean. Some of the texture even shows through. So it's not like a total lost cause, but I don't think you can even notice it on the camera. So you do have to be a little careful with those, and any of your, even if it was on this side with the textured PEI. But I bought another one of these. It hasn't come in. I think it comes in today. That has a carbon fiber pattern on it. So I'm going to try that one. It's actually PET. This one's supposedly PEO. So PEO I couldn't find an actual definition of what that is, I think it's just a more generic category that PET might be within. I'm not certain on that. Okay, so that's all of that. And here are those nozzles. They came in. So the true Bondtech CHT nozzle, the one that these are emulating but not copying, they are a different thing, is like $20 plus shipping for one. This is $11 for 5. So, including shipping from Amazon. So much cheaper. I haven't tested one out yet. We might. We have to do our photogrammetry, so we can't do this first. But here's what. Let's see. We're gonna have to zoom way in to get a chance to see what's going on here. You can see that, but it's very blurry. Oh, there we go. All right, so see how it has the 3 little divisions in there? It is going to attempt to split our incoming filament. So our filament would come in here and then be split into those 3 separate strands, which the idea there is that the 3 separate strands would have a smaller cross-sectional area, and I'd be able to more quickly melt each individual versus melting one solid strand. Now, is it going to go off to the side somewhere and mainly go through one of them? Maybe, I don't know. I haven't put it in there yet to find out. Another thing is the Bondtech is all one-piece brass with a nickel plating on it. This is definitely 2 different pieces. So I've got brass for the main nozzle, and this little insert, I think it's copper. A little copper insert there. So we'll see. I will put these in at some point. I just don't know if I'll do it during the stream today because we'll be doing other things. But and we'll see if they make any difference at all on the flow rate. So according to our test like this, we know a maximum flow rate for the regular nozzle. So there's not a Bondtech CHT in there. It's just a regular hardened steel 0.6 millimeter nozzle. I should get better heat conduction if nothing else because this is brass, most of it. So I should get that. It is 0.6 millimeter diameter. So it is roughly the same. I won't be able to print abrasive stuff with this, but we'll see. We'll see what happens. Okay. Let's look at our photogrammetry. I don't see anything else over here that we need to talk about on that side. So photogrammetry is capturing real-world geometry without having to go to CAD and model it directly. So we did a thing earlier where I took a what did I take? I took a Polycam app on my iPad, so iPad Pro that has the LiDAR sensor. Doesn't have to be an iPad, just a piece of hardware like a phone or a tablet or whatever that has LiDAR. And Polycam is the app. And there are others too. Polycam seems to be the leading one. It's not free, though. They might have a free trial, possibly. I don't know. But I took that, scanned the front of the car, or the truck. It was a truck, a 2008 Ford Ranger. Scanned the front of it. Used that scan data to go into Fusion 360 and build a hood scoop based on fitting to the geometry of the scanned hood of the truck. So the downside of that is that LiDAR technology needs a piece of hardware that has LiDAR sensors on it, and you may not have that. So, and you may not want to pay for Polycam, which does have like I think it does a subscription. I don't think it's one of the ones where you just buy it. I think it might be, but I think it's a subscription. So you may not want to do all that. So there are ways to go and get similar data, and in some cases even better data, but a lengthier process, with taking pictures. So taking your cell phone and taking pictures. I actually did use a camera, so I used this camera here, if I can find it. So I used this guy. Yeah, it's in the thing up there. I used this, So this is old Canon D, I guess. Something like that. Whatever it is. Several years old, but it worked fine. But your cell phone would work fine. Or at least it would work. You can get better pictures from a camera that you can control more things like the f-stop and the exposure and all that kind of stuff, ISO. You might get slightly better pictures that would lead to better mesh results, but your phone will work, and actually a lot of your phones are maybe even better sensors than what is in that older camera. So the software we're going to use is, let's find it. Here it is. So Alice Vision is the parent, and what we're actually looking for is Meshroom. So Meshroom, free, open source, 3D reconstruction software based on the Alice Vision framework. So, and you can make a donation if you want to support them, but you can actually download it completely free. It does only have Windows and Linux. I don't know that there's a Mac one. Also, this little line right here is important. Let's see if you can, let me maybe zoom in on that because it's important before you go and try and do all this stuff. To fully utilize Meshroom, you want an NVIDIA CUDA-enabled GPU. So that's a graphics card from NVIDIA that has the certain CUDA-enabled processing. If you don't have that, you can use the software, but you can only do the draft meshing. So you won't be able to do the refined meshing. And it might take longer also. So just be aware of that. That if you don't have, like probably many laptops don't have that, I'm not sure. But if you don't have a desktop that has that particular graphics card capability, then you might be a little disappointed in what it does. There are other versions of photogrammetry. I think at one time Autodesk had one, but I don't know that they have. Well, so here's one, photogrammetry in your browser. I haven't tried that before, but maybe you can do that. Here's what I was actually looking for. So there's several of these different things, and your phones do have some photogrammetry apps built in. In fact, the Polycam, even if you don't have a phone that has LiDAR sensors, you can use just the photogrammetry version of Polycam. So there are different ways to do this. I'm going to show you in Meshroom. I've used it several times before, and it generally works good, although it's slow. Now, what I did, let's open up, where does Meshroom at? Got too many windows. Here it is. So this is already processed. So here are the pictures on the left hand. I'm scrolling through them. Those are the pictures I took. So how many is that? 31 pictures. 31 input images. It estimated 20 cameras, and then there are 11 of the 31 pictures that it couldn't figure out what's going on. So maybe they were too similar to previous pictures I took. See, like this one, it didn't use that one. It's got the little red mark on it. Didn't use that one. So it didn't like those for whatever reason. Maybe they're too washed out on the exposure or something. So there's several of these which are exactly the ones, well, not all of them, but these are exactly the ones that I wanted it to use, but I didn't have enough overlap, or it's too overexposed, or there's some reason that it didn't use these. So my goal was to, put something like this. So this is a side air vent for like getting air out of an engine compartment or something like that. Most of these are fake. They don't actually do anything. They just stick on the side. But anyway, my goal was to make one of these. This particular one is $200, and it's not even in stock. So I'm not going to do that. But I thought, well, let's try and make one of these. A printer, most printers anyway, could print something this size. And so like the hood scoop we did was too big to print on most normal printers. So this is within the realm of something we could print. So that was my goal, and so that means I needed this geometry right here, and a lot of the pictures that it was rejecting were of exactly that spot. So we did have a little bit of problem, but the process is you drop your pictures into this image gallery. 30, well, it only used 20. That's on the low end of the number of pictures you want to have, but that's what we had. We had 20. I might go back and try to get some more someday. It looks like they're all kind of overexposed a little bit. And then this down here at the bottom of the screen, that's our pipeline. And it's all completed right now, but you can modify this thing. You can change parameters in each one. I did none of that. I just dropped the pictures in here and hit start and let it do all of the default processes. But if there's things that you want more detail on, or you want it to go faster and less detail, or you don't even want to do some of the steps, then you can go in there and you can modify a lot of the parameters. But I did not do any of that. So what happens is it goes through, whoa, there we go, and it will, you can see all these little, let's see if we can get a little closer. All these little pictures here are where it estimated I was standing when I took a picture. So that would be more correct orientation. It's more like that. And that's roughly what I did. I walked around and took pictures. It didn't like any of the ones where I was lower trying to get a upward view of the fender. It didn't like any of those. It rejected all of them. So it only got these top ones. And then it generates this, point cloud. Well, I don't know if this is necessarily a point cloud. This is more like a depth map or something. It's just an estimate. So it gives you that to start with. Structure from motion is what it calls it. So I don't know exactly what the definition of what to call these things, but that's what it calls it. Let's see if we can zoom in on here. So first it goes through and grabs the cameras, figures out which one of the pictures it can use, where did it probably come from, that kind of stuff. If you use a camera that it knows, like the meta information in the picture itself tells it stuff about how the picture was taken, that will help. Some phones don't give you that information, or it can't read it or whatever, but generally the cameras can, and newer phones I think it can too. So it goes through and processes that stuff. Then it does some feature extraction and image matching. So it's trying to identify in these pictures that I took, it's trying to identify, hey, that little line there is probably also that line there, and kind of trying to match stuff up. And then it tries to do the actual matching part. Then the structure from motion is where it is trying to recreate the geometry that must have existed based on all of these pictures. So that's why taking more pictures is generally better. It also has trouble with shiny stuff and transparent stuff because it will get confused if it can see through the picture, like to the inside. Like you'll notice the headlights don't come out good at all on this, or if there's a particularly shiny. Now this truck has not been washed in a long time and it's not generally shiny, but I was kind of early in the morning and there are highlights from the sun on different edges, and it had trouble figuring out what to do with those, and you'll see that in the geometry that it makes. So this is probably one of the longer steps. This whole process from dropping the pictures in to getting the final mesh out was probably an hour. My computer's not super high end, but it's not really weak either, so it's kind of just a mid-range computer. These run all locally on your computer. It doesn't send them off to a cloud to process, so it will possibly take a while. The 1 hour processing for 20 images is what I've kind of experienced with this in general. You can speed that up by not having it do as fine of a mesh, not filter the mesh. You can remove some of the processing and make it a little bit faster, but it's always going to be a pretty lengthy process. So don't think you're going to drop the pictures in and wait 5 minutes and it's going to spit out the geometry. It's not going to do that unless you have a much faster processor than average. The general flow is that now it will try to create a depth map, try to filter that to get rid of some of the noise. Here's the meshing step. So meshing is near the very end of the process. So if I think I can double click on this and get it to, yeah, so there's our mesh. Let's close off the structure for motion. So there's the mesh that we end up with. So there are, you can definitely tell it's a truck. You can definitely also see that the light being reflective and glass transparent, it just can't figure out what's going on with that. I did not take many pictures over here, so it didn't even, you know, it just kind of, they're in the background, so it does generate something. I took most of the pictures focused on, you know, this area, which that's, you know, it's definitely lumpy. So it's not like this smooth, nice geometry, but you can definitely tell what's going on there. Now, unfortunately, the exact spot where I wanted to get the most detail, it's really lumpy. So I went back to some of the pictures. I don't know if you'll be able to see, but right, here's the Ranger badge, and I guess it does bump out, and I guess it kind of protected this little area from all this other, you know, like mildew or whatever that's on the truck, and it's still shiny right there. So that one spot where I wanted the detail the most was a little too shiny, and I should have, and it rejected, remember, it rejected most of the pictures where I went and took extra detail from there. So I needed some more, needed something to go on there. So maybe I should have sprayed it with one of my laser scanning sprays. That might have helped. Maybe not. I didn't try it. Maybe put some tape there to help it track, you know, some kind of flat masking tape or something, help it track what's going on there. I'll show you what I did to fix it, but so we did get that issue. So this is the mesh that it generated based on the pictures. Then it does mesh filtering. You could drop this part out, but basically it's trying to refine stuff. I'll show you once it loads. All right, so you can kind of see, oops, so there's a slight difference in them. So there's the original mesh, there's the filtered mesh, and it's a little bit cleaner. I probably could have done a little bit, it basically did a little bit of smoothing. I probably could have gone into this block and refined how much smoothing it did. So there's a lot of different options here that I could have done, and I didn't. So I just, again, I took the default ones. And then texturing, it can actually go and put, since it took color images of the truck, it can go in and put a texture map on top of it so it looks like the picture. Now you can see there where it's now it looks like the truck does, although it's got these holes right here. These holes, those are from highlights from the sun. You can even see in this picture how there's a little highlight right there. Those highlights were too strong for it to figure out. So I definitely needed to do something to better prepare the surface here to get a little bit better geometry. When you put the texture on it, it actually looks decently good though, right? Other than the big holes in the mesh and the holes over there on the fender. But it looks like, well, you can definitely tell what it is. But without the texture, you can still tell what it is, but you see more of the lumpiness. All right. So that whole process was an hour. I didn't do any optimization or make it any better, or didn't go take more pictures to try and get a better result over here. I just went with this because that's what I got. So a couple of things about taking the pictures. If you can try to take them without getting your own shadow in the picture, take them at the same time. If it's outdoors, then if you can get overcast so that the lighting stays pretty well even and you don't have those strong highlights, that will help. Outdoor stuff is just harder, particularly when it's going to have reflections and transparent parts like that. If you were taking a scan of a tree or something, then you wouldn't have nearly those same troubles. But you take as many pictures as you can. Obviously, the more you take, the longer the process is going to take on the computing side. But you drop them in, hit start, and let your computer run for an hour or more, depending on what you're doing. And you'll get something like this. So this one, it's not perfect. And we could go back and clean things up, but I had what I needed. I had something that gave me an idea of what's going on here. And this is free, assuming you have a computer, assuming you have some way to take pictures. I don't know what it would look like if I could only do the draft mesh. So if I didn't have the NVIDIA, I don't think I could do I don't know where the draft, where it would cut off at. But there would be somewhere in this process on the meshing where it would not do a refined mesh. It would only give me a more rough mesh. So I'm not sure where that would have occurred. I think it's in this block or right before this block, and I wouldn't have gotten quite as much detail. So then it saves it to a folder, and you get a OBJ is I think what it saves. If I look at the mesh, yeah, well, you can actually save several different types. There's a STL. The difference between OBJ and STL is that the OBJ will have materials built in the picture itself, so that you could, if you were putting this into a game engine or something like that, it would actually look like the truck that you took pictures of. It would put the texture on it. I actually did export it OBJ, but you could also export it as STL. And then I'll close this. I'm going to discard changes because I don't think I made any significant ones. Let's see. Then I went into, I think the next thing I actually did was I went to, Mesh Mixer. That's where I went. So let's go over there. I'm not typing. There we go. So I went to Mesh Mixer because there was an issue with importing the mesh straight from Meshroom to Fusion 360. So I went into Mesh Mixer to fix that issue. So let's see if we go to where did it save it? It saved it in here, project folder. There's cache. There's mesh filtering. There's a random number. There's a mesh. So I think this is the filtered mesh OBJ file, and I opened it. Again, Mesh Mixer can struggle sometimes with larger amounts of geometry. It's translated in a weird way. It's below the ground. There's the ground plane up there. So we could go into edit, transform, and we could, bring it up there and make it more flat, something like that. That looks good. And then we could do more on like getting rid of some of this stuff that we don't want. It's thinking. Sometimes, like I said, Mesh Mixer will want to crash on you with these larger meshes, which it is not crashed right now, but it's definitely acting sluggish. And it could be because I'm not giving enough resources to Mesh Mixer because I'm streaming and everything. Because when I did this without streaming, it actually worked relatively normally. There wasn't a lot of lag. I just I think it's locked up. But anyway, what I did is I went to analysis, and there's an inspector in there, which Oh, all right. Maybe we'll do. The inspector will give you, hey, all of these parts they have holes or whatever, and I just went and auto repaired all of them, and I think it left one or two. And yeah, it left one here, so I said done. And then what I did is edit plane cut, and I just chopped off most of the stuff that I knew I wasn't going to use. So I wasn't going to use any of that, so chopped it off. Did another plane cut to chop off a lot of that, except I want the other side. I want to keep the other side. Let's see, I'd like it to be straight. Yeah, that's good enough. And then I didn't want that stuff on the bottom either. So we'll cut more like that. And then I chopped it off here. Just to get rid of extra stuff. So now I've got more focus on what I want. You can also see how lumpy the mesh is, and particularly right where I wanted the data. But I did that. I think I might have run inspector just one more time to see if there was anything. It said there's nothing. It's fine. It's an open mesh, which is fine. You know, there's nothing on the back, but that's okay. I think it scaled really weirdly. Let's see. Yes, it's 1.64 tall, so that could be meters, I guess. 2.63. I don't know if that's meters though. So it's got some scaling issues, but I saved that because in the Meshroom piece of software, it doesn't really have any way to scale anything in there because it doesn't know how big a truck is or how big a tree is. It doesn't know any of that stuff, so it just tries to generate the geometry, and you have to go scale it later in some other piece of software to get it the right size. So we'll do truck 1. Oh wait, but that's saving the project. I want to actually export this as a STL file. There we go. Okay, now I have a STL file that I should be able to bring into Fusion 360. I don't want to save any of that. That's fine. Oh wait, so Fusion 360. Here's what I did. So what I ended up with anyway. So there's the truck. That's the way I chopped it up the first time I did it. And then there is our little side vent in the block view. So remember when we were doing the forms last time, usually it works better to model in the block view and then check the smooth view. So let's turn on some of our lines. So there's the block view, and there's smooth view of what it would look like. So that's what I modeled. Now how I dealt with, there's the big holes right where I wanted to put this thing. How I dealt with that is I just put a little patch panel on there. So I kind of just used the same form modeling processes that I used before and dropped on a little patch that covered up the hole, just so I could kind of model this a little better. Most of the time I had that patch off once I was done with it though, and I was just using this view. And then even a lot of the times I was just using this view. Well, actually this view, I guess. Now, this model has some problems in the edge loops that I was dealing with, particularly when I went to thicken it. It got really kind of, I had to do some manual editing inside here to get it to do the export. But we did end up with something that was usable. So I haven't printed it yet. It does fit. That was what was on here. It does fit. I haven't decided how I want to print it, or if I want to work on it more and print it. You can see when I exported it, there are little facets here. I believe, and all in there, I believe I could get a better export from Fusion 360. In fact, maybe we could try that. Let's see if there are options here. So I just did this, and doesn't really give me any options, does it? So what I need to do is I need to go in and see if there are some options that I can set on the mesh density when it goes to export, because I do have some issues on this thing. Little stretched out holes and things like that, facets in here that I don't really want. Now we could print this and then Bondo or whatever over the top of it, but I'd like for the print to be closer on its own without having to finish it myself. But so it does fit, but it's going to be filled with support material if I do it this way. So I haven't really decided. I could print it on its end, but then there's not a lot holding it up. So I would need to add a lot of supports to get it to not wiggle around when it's printing. Right now it's printing this way. So I haven't decided how exactly I want to print the thing on here. But that's the general idea of photogrammetry, which can be free using stuff you already have. Or there are paid versions too that use photogrammetry, and like the Polycam, that photogrammetry doesn't happen on your phone, I don't believe. I'm not 100% sure, but I assume it sends it off to their servers. I can't imagine your phone being able to process the photogrammetry in the amount of time that it actually does. So I assume it sends the pictures that you take off to their cloud, and the processing is remote. And that's why I don't think it's a free version on Polycam anyway. The Meshroom is local though, so you don't send your pictures off anywhere. They stay on your computer, but that also means that your computer has to do all of the work on processing those pictures, and that's why it has the limitations on certain graphics processors and things like that have to be available for it to really do the work. All right, we do have a few minutes. Let's close. Actually, let's leave that open. Let's close Fusion. It might take a while for it to close because it's got all this data it's got to save. Yeah, so it'll close eventually. If you wanted to try this photogrammetry out, one of the optional assignments can be photogrammetry, or maybe you could even do your technical report on, best practices for photogrammetry, using whatever Meshroom or Polycam or maybe some other piece of software. You can get some good results. It just takes longer on the processing side of things. Let's see. Let's go over to, this was me trying to work out this. There's what I was originally aiming for. This was me working out where the edge loops are going to need to be. Basically I was looking at, there's a corner. Well, let's mark them down. Where did my pen go? I lost it. Well, I don't know where the pen is. So I was thinking that there's a corner there. So 1, 2, 3, 4, 5 corners. So I couldn't just have a rectangle. So I was matching up. I really need to find the pen. I do not know where it ended up. Huh. I don't see it anywhere. I'm sure I put it in its holder. So what I was doing was I was matching this corner to here, this corner to actually here. So I would start out, when you create these forms to start with, you start with a rectangle usually. There are ways that you can make faces and make different shapes, but I've always started with a plane and worked from that part, and the planes are rectangles. And then this corner maps to this little spot. This corner maps to here, and this corner maps to there. And so if you can kind of think ahead of time on how you're going to have to divide up your plane, you know, do the insert edge and that kind of thing, then it might help, because I ended up with a few issues on mine when I went to complete the form. So you can model and deform the plane and do all kinds of stuff to it, but if what you created can't be converted over to the T-splines, which are more the parametric side of Fusion 360, then it doesn't matter. You know, you made the form, but you can't actually do anything with it. You can't export it as a STL or anything like that. So I was having issues after I thickened it to make it, you know, solid. I was having issues with things intersecting, self-intersecting lines and planes that were overlapping, stuff like that. And it was because I didn't spend enough time beforehand thinking about where I'm going to have to divide up the plane, and I was doing it more on the fly. So it would definitely, if you want to try something like this, it would definitely be easier on the whole process if you spent a little bit of time trying to map out how you're going to model it. All right, let's go change the nozzle on this thing. So changing the nozzle, we've done that once on the stream before, but let's do it again. One thing you need to do is take the filament out. If you don't take the filament out when it's going to be in the nozzle, it's not going to release the nozzle, so you'll have problems. So we're going to heat up and try and get this nozzle put in there. I don't know if we'll get to print because I don't want to take too long. We have about 20 minutes left, and I don't want to take all of that time. Sonic pad's booting up over here, so I can't heat it up until the Sonic pad's booted up. That's one tiny downside. Normally I just leave it on, but that is one tiny downside, is it takes slightly longer to boot up, but it's booted up now. So I'm going to preheat. That's PLA, so I'm going to preheat for PLA and let it do that. I'm going to see if I can get the camera in a usable spot so that you can get an idea of what's going on here. So you'll have to move. So let's see. That shroud is going to be in the way for a lot of this, but you can also see more of the scratched up area. Let's see, I'm going to need a wrench and maybe a pair of pliers. Okay, so you get those little tiny flat wrenches with the kit. They are tough to use, so I'm going to use a tiny little wrench. I need a metric set of these, but this works close enough. I think this is 9/32 for that particular size, and that'll work for the replacement nozzle too. It's close enough, but the chances of you having a 9/32 inch wrench floating around are not great. So I happen to have one. So a lot of times you're stuck with those little flat wrenches, which they will work. The main thing is you have to heat up the nozzle to break it loose, and to remove the filament, which I think we're ready to do that. Oh, all right, so the filament snapped. The filament snapped off at the Bowden, or well, not a Bowden tube. I guess it is, but it's not the same as the all right, so let me show you what I've got to do now. So now that the filament broke off way up there, I could just try retracting it, I suppose. Let's control extrusion. Let's retract and see see if it'll do that and spit it out the back. Yeah, it is. All right. So we'll just do that. Normally I like to manually push filament through and then pull it out, but I can't do that now. So now I've got something to grab a hold of back here. And all right, now the filament's out. Okay. Let's see. Now what we need to do is we need to take our, I really don't know if I can get down in there very well. Oh, you know what? I could raise the Z-axis though. Let's see, move Z. Oh, I have to home everything. So I have to home things before I can move things. I'm looking for my tweezers. Not seeing them. Everything's, oh, here they are. Everything's kind of moved around right now. So has to home the Z. Okay, now we can move Z. Well, it's going to move up on top. Let's see. You can. Okay, now we're getting close to where you can at least kind of see what's going on. So I got to remove the little silicone part, which is, it itself is not usually too hot, but everything around it is. So got that out of the way. Actually, it's really pretty hot too. Now, if you don't heat the nozzle when you go to break it loose, you stand a chance of either shearing the nozzle itself. Now, this one's a steel nozzle, so that's probably not going to happen. Or twisting or shearing your heat break. So it is best to heat up. And what I was saying with those little, even this one's, this is not a big wrench, but those little flat ones, they get hot so fast that it's tough to hold them long enough to actually break it loose. Actually, that's the wrong end. That was the 5/16 end. So there we go. Now, sometimes you have to hold the heat block while you're doing that. I didn't need to do that for this particular case. I'm very aware that this thing is hot. You know, you're tempted to just reach up in there and grab the nozzle and twist it out, but it's 200 degrees. So we're gonna, there it goes. All right, so see, I should have thought about that. It got some gunky filament on my bed. I might have another spot that's going to be messed up. So there's our old nozzle. We're going to put it, you have to be careful where you put it down because it is hot and it could burn the surface that you put it on. Where's our new one? All right, so here's our new one. I'm going to put, you can't focus on that. Now this, you don't have to have the hot end heated up while you initially start the nozzle. But once you've got the nozzle in place, then you do have to heat tighten it. If you don't heat tighten it, you're going to get jams and leaks. But if you're reluctant to reach in there and get it started by hand because it is 200 degrees still there, then let it cool down, start it by hand, and then come back and heat it back up and tighten it another. Once you get it snug, then tighten it another, I don't know, 1/8 of a turn or so to really seat it in. So right now I'm just, all right, so it's snug. It's touching the heat block now. Now is when you would want it heated up. Mine's still heated up. Now you have to grab the heat block so to hold it back up, because if you don't do that, that's when you can shear off your heat break and tighten that 1/8 of a turn more. If you don't do that last 1/8 of a turn, then, and it doesn't have to be exactly an 1/8. I'm just saying that as far as like you need a little more tightening done. So if you don't do that, the the backside, the backside of your nozzle where it would touch the heat break is not going to be tight enough against it, and filament will come out in that gap. Even if the gap is very tiny, it will still squirt its way out there, and you'll get clogs and all kinds of problems. Put this guy back on. Again, you might want to wait till it's cooled down. Generally they'll snap in place. That one did. Now we can reload filament. I guess I'll put some of this back in there. I don't know why it snapped on me, but it's been printing well, so I'm going to put it back in there, finish it up. Let me cut off some of this part that's brittle. This filament is really old. Like I said, I bought it 2018 or so, maybe 2019, and just never used it. And now the company that made it doesn't make it anymore. So I'm going to go ahead and use it all up. So I'm loading filament. I have to usually take this little bar off to guide the filament into the tube here. Every great now and then it'll line up on its own, but usually not. So usually have to do it this way. There we go. Now we got to put our bar back on. This is what holds the tension on the filament, holds it up against the drive wheels. And let's extrude some filament and see if we can make sure the filament comes out of our nozzle. Let's see, where is extrude in this thing? Control, extrude. Let's do 25 millimeters. All right. All right, stuff's coming out, so that's good. Let's do another little purge there since it didn't all purge out. All right, so a couple of things. We've switched from hardened steel to brass, so that means that we have to be careful with abrasive materials. It also means that our PID tuning is totally wrong, because we had it PID tuned for a steel material with a very different thermal conductivity than a brass material that it has in there now. So we should actually be able to print a little bit better with brass, as long as we don't do abrasive stuff. So to do a PID tune with clipper, remember it's actually pretty straightforward. Let's see if I can get us in our clipper. I don't know which address it's on. There we go. So clipper has a PID tune macro. We can just click that button and it will send the G-code commands to do the PID tune for us. Apparently part of it is homing. I don't know why it needs to home to do PID tune, but it's going to. So it's homing right now, and it's going to, now I don't know the defaults on that. Once it shows us, I think it'll show us the defaults, or I guess we'll see what temperature it's going to go to. So this is just a default PID tune, and so you might want to do one with more iterations or to a specific temperature or something like that. It looks like it's going to PID tune to maybe, right now its target is 195, so I don't know if it's going to go down to 195 and then go up, or if 195 is the target. Oh, it looks like it's going to 200 is the actual target. So it was cooling off, now it's going to go to 200, and then it'll cool off down to 195, and it'll oscillate some number of times. I don't know what the default for this little micro is, but you can kind of see it in our, oops, you can see it in our heat window here, tracking where it's way overshot, right? Because it was tuned for steel, which is going to heat much slower than brass. And so that first time it was told to go to 200, that little dotted line is 200. It went up all the way to 205.5, 206 nearly. So it way overshot. So it's got to recalibrate based on a totally different thermal conductivity. So would this affect your prints? Not a lot, really. Unless you're trying to do really controlled printing, it's still going to print fine, mostly fine, but you might notice some surface defects, not big defects, but maybe some over extrusion on some layer changes or something like that. But you can see how it's way overshooting and undershooting. You would just have harder time controlling the nozzle temperature tighter. It could still control it, it just would have these overshoots and undershoots if it never needed to change, or if there was more demand of filament coming out, then it might struggle a little bit. So it's easy enough to do a new tune, particularly in Clipper, and get a little bit better control over the temperature of your nozzle. So it looks like it's done 1, 2, 3, it's on the 4th cycle here. I bet it's going to do 6 cycles and we'll have a new tune. I don't know that there are any other tunes we would really need to do. The maximum flow rate, that's what our whole deal was, is we wanted to see if that changed. We'll have to do one of those longer prints to see if that changes though. We could do some more of these to see if that would change. It's possible, I don't know. But I'm not going to do that on the stream. Those prints take 30 minutes or something. So we've got a new nozzle. We'll try printing and see. I will do one of these to see if we can get any more, or if we get less flow rate than what we had before. I'll do that off camera and report back sometime next week. Also next week, hopefully we'll have some maybe not prints from our Rook 2020, but we'll at least have a Rook 2020 to play around with. I don't know if it'll print next week or not, but we'll see. All right, I will see y'all Monday.